Solving equations with variables on both sides. Lesson 2-4. This is the last lesson in this series of equation solving ones. To solve an equation with variables on both sides, you're going to want to use inverse operations to collect the variable terms on one side of the equation. So we got to get all the variable terms onto one side, we got to get all the plain numbers onto the other side, so that eventually we can go ahead and multiply or divide to get the variable by itself. Somewhere on your note page, probably somewhere below all of the boxes in the middle, you're going to want to write that down. Collect the variable terms on one side of the equation. It is easiest if you keep the coefficient, the number in front of the variable, positive, just because then there's fewer times when we lose track of that negative sign. So anytime you can make it positive, that's usually a good choice to make. So we're going to start with a pretty basic example here. You can put this in the box where it says one solution. So you're going to write the equation down and the solution. It's obviously going to go further than the box. So we want to get all the variables onto one side, and I like to keep the coefficient positive. So since there's more n's on the left than the right, I'm going to take 5 n's away from the left side, and I'm going to take 5 n's away from the right side. I remember I have to do the same thing on both sides, and I want the n's to disappear from the right side. So I want to make them equal 0 over there, so I just do the opposite. And then over here, right, on the left, 7n minus 5n is 2n's. I still have this 2, so I just drag that down, and it's subtracted. Drag the equal sign down, and drag the 6 down. I can put it right next to the equal sign because there's no more 5n's. And now look, two-step equation, the kind that you're so familiar with. Right, you're going to add 2 to both sides, and we get 2n's equal 8. So 1n equals 4. Now, the big pitfall that I start to see happen on these is that people get confused between these and equations where all the variables are already on one side. Look at how this problem is a little bit different than this one, right? If I have 4x minus 2x plus 3 equals 7, right? This math, I just do what it says. It's already all on one side. So that would be 2x's plus 3 equals 7, right? And then I would keep going and I would solve it. Now in the problem we just did, we had to do the opposite of the 5n because I want to move it from the right side of the equation to the left side. So make sure you know the difference between moving things from one side of the equation to the other when you're using opposites and when you're just going ahead and combining like terms on a single side. To solve more complicated equations, you might need to first simplify by using the distributive property or combining like terms. So they're not all going to be as simple as that first one. Find a spot somewhere in that bottom half of the page to write this example down to. It still just has one solution, so don't fill it into either of those other boxes in the middle of the page. This time we need to do a little distributing. Anytime you see those parentheses, the first thing you want to do is get rid of them. So let's go ahead and distribute, and on the right side we'll have 5x plus 50. I made this equation up and I hope it was going to work out. I think it will. Okay. Nicely, I mean, without yucky fractions. And then I want to get all my variables onto one side, and I like to keep them positive. So I'm going to move the 4x's this time because that way, right, I will have still positive 1x on the other side. So I'm going to subtract 4x's from each side. That makes them disappear off the left side. And I'm left with 2 equals 1x, or just x, plus 50. Now I have a one-step equation, actually. So just go ahead and subtract 50 from each side, and I'm left with negative 48 equals x. Right? And I could go ahead and check that, although definitely on this one it looks like I would need a calculator to find out for sure. I'm not going to take the time up on the video. If you've got your calculator handy, you can check my work for me. So here's another one. This one's a little more complicated. You can go ahead and just watch this one unless you're dying to write it down. We got a lot going on here. We got some distributing on the right side. We got some things to combine on the left side. So the first thing I'm going to do is I'm just going to go through, I'm going to zip zap, add the opposite here to get rid of all these negative signs, minus signs, and replace them with negative signs. And now let's do a little combining of like terms. So I've got 4 plus negative 6a plus 4a makes negative 2a on the left side. And on the right side, I can't even combine like terms yet because first I have to distribute. So I've got negative 5 times 7 is negative 35 plus negative 5 times negative 2a. Those are both negative, so I end up with positive 10a. I keep going. Did you notice this is starting to take up more paper? More screen? Welcome to longer equations. Combine like terms. Right? Negative 1 plus negative 35 is negative 36 plus 10a's. Now I can finally get all my variables together on one side, and I want to move them to the right. Let's change colors so you can easily see what I'm doing. I'm going to move them to the right so that they stay positive. So I'm going to add 2a, and I get 4 on the left equals negative 36 plus 12a's. And let's hope I don't run out of space here. I'm going to add 36 to both sides. And I get 40 equals 12a. Is that going to be right? I don't know. We've got the box down there in the corner, so we'll figure it out in a second. Let's move over here so we have enough space. So I'm getting that a equals 40 over 12. Now I didn't practice this in advance, so we'll have to see if I'm right. Divide both those by 4 to simplify, and we get 10 thirds. All right, let's see if I'm right. If not, it's going to take a lot of video time to fix it. All right, so let's use the magic eraser. Uh-oh, it's not magic erasering. Let's try the arrow and we'll move the box. Well, there's a box, but there's nothing below it. I'm going to have to hope that I'm right. 10 thirds. I don't really have time in the video to check it, so I don't know. I'll get back to you in class. If you think I'm wrong, you can let me know. It's very mysterious. There should be an answer under there. Well, let's move on to the identity. And there is a place for this up in your vocabulary section. An identity is an equation that is always true. Always true, no matter what value is put in for the variable. Okay? We say that the solution set for those problems is all real numbers. Okay? What that looks like in practice is that your variables cancel out, and what's left over is true. Okay? So it would be something like this. 2a plus 2 equals 2 times the quantity a plus 1. When you go to solve that, right, you're going to move the 2a's, right, after you distribute all onto one side, and what happens? They go away, right? You can see that the left and the right sides are exactly the same. So you would end up with no a's left and 2 equals 2. So, right, that's an identity. Okay. Some equations, though, are always false, right? And we say that their solution sets are empty, and you can either put 0 with a slash through it, or you can make little wiggly brackets called braces with nothing in them. Okay, there's no solutions. The variables cancel out, and what's left is false. So instead of like the one we had previously, if we had 2a plus 2 equals 2a plus 1, right? The a's would all drop out when I tried to subtract them, right? But 2 does not equal 1, right? So that problem has no solutions. Okay? It's a very frustrating thing when you solve an equation and there's no solutions, but it does happen sometimes. Let's look at a couple examples, one for each that you can put in the boxes in the middle. So you should be expecting that these either have infinitely many solutions or no solutions, all real numbers or no solutions. So let's combine some like terms. I've got 10 and positive 1 makes 11 minus 5x's. And on the other side, I have 7x and negative 12x. And that's negative 5x plus 11. If I try to get my x's together on one side, right, look what happens when I add 5x's to both sides. They just cancel each other out. right? There's no 5x's, there's no 5x's. And what's left is 11 equals 11. That's the identity. For your answer, you write all real numbers. Right? X could be anything in the whole wide world, and no matter what, right, the two sides of the equations are going to be exactly the same. Okay, so X could be anything. So that's your example for many solutions. Now let's look at a no solution example. Once again, we got to combine some like terms. They try to trick you a little bit here. So we've got 12x's plus 1x makes 13x's on the left, minus 3. And on the right, we have 5x's plus 8x's makes 13x's over there. Notice when I'm on the same side already, I'm just combining like terms. Okay. And then we still have minus 4. Now, if you accidentally start moving things to the left or the right before you combine them, it's still going to work out. You're going to find out that eventually all your variables cancel out, and right, you're left with right, maybe a slightly different equation than what I have here, but right, it's still going to be false. Okay, so I have negative 3 equals negative 4. Right? If you somehow did this and got 0 equals negative 1, that's still false. Right? So there's no variables left, and what's left at the end is not true. Those are not equal. So at the bottom, right, we would just write no solution. Right? You can write it in words if you prefer. I like the 0 with the slash through it, and you can also use the empty braces. We'll do some more problems like this in class so you see even better how they work before you do some practice on your own. But that's it for solving equations with variables on both sides. It's really about using all the tools in your toolbox that you've been learning both last year and this year.